looking at the formula, writing the three. Remember, we said that we're practicing all three. Molecular formula, the fully displayed structural formula, as well as the condensed formula. All right, so we started off with alkanes yesterday, but we're going to move on to alkenes. All right, now our general formula for alkenes, CnH2n. All right, and what you're going to realize is that my alkenes will be 2 hydrogens less than your alkanes. So my alkanes was CnH2n plus 2. Now you're noticing that the general formula for alkenes is CnH2n. All right, now what will cause something like that? What happens is that because you have the presence of the double bond, remember now, because you're going to have that double bond between, I now have one less bond for those carbon that will possess the double bond. So remember, carbon atom can hold a maximum of 4 bonds. Usually, based on how we draw, this bond here will be, or this one will be a connected bond between another carbon atom, right? Now, if we are using a double bond, it means that we're going to have to take one more bond and place it here to form 2 bonds between it. And so now we are one less bond for a hydrogen atom to be bonded to that carbon atom. So let's start with the simplest of them all. Now we're going to start with ethene. Can anyone tell me why is it that we can't start with methane? Why is it that methane does not exist, or methane? Why doesn't it exist? I must have a double bond between a pair. The prefix meth means 1 carbon. Now, if I have a single carbon, how do I get my double bond? I cannot. And so for alkenes, the prefix meth does not exist for them because I have to start with minimum 2. So we're going to start with the simplest of them, which is ethene. So ethene means that I have 2 carbon atoms. And so I'm going to plug it into my formula. Wherever I see N, I'm going to substitute and put the number of carbon atoms. So CN H2N. So what would my molecular formula be for ethene? C2H4. So this would be my molecular formula for ethene. Now that's one example. We need to now look at, so this is molecular. We need to now look at our structural formula. How do we draw this? Now, whenever we're drawing, ladies, always start with your carbon backbone. That means that it is your carbon chain. So we always state in terms of how many carbon atoms. So if I have 2 carbon atoms, I'm going to start with that 2. 1, 2. If I had 6, I'm going to draw the 6 carbon atoms. Then now I need to remember what's my functional group, because each family has a uniqueness to them. For my alkenes, the uniqueness is that it has a double bond. So a double bond must come between a pair of carbon atoms. I only have 2. There's nowhere else for me to put it this time. All right. Now, how many hydrogens should I have bonded? 4. See there? And so my structural formula for ethene will look like this. Now we need to move on to our third. We need to do our condensed. Now for our condensed formula for our alkenes, it's going to require us to actually show where the double bond is positioned in the structure. All right. So you remember when we were doing our alkanes that we can just write CH3, CH2, CH2, CH3, and we were good. We can't do it so much with the alkenes because we need to show the double bond. So to write our condensed formula, we are still going to write carbon number 1 and how many hydrogens attached, but then we're going to show the double bond in the condensed formula. All right, and that's your example for ethene. Awesome, ladies. All right, now we're going to jump. I'm going to use another example. All right, so instead of us going 2, then 3, then 4, you can practice that. I want us to look at a larger alkene. All right, and so I'm going to choose pentene as my second example. All right, so we're going to look at pentene. All right, now that you see the name, how many carbon atoms will pentene possess? So because the prefix, ladies, is pent, remember we work with prefix now. So because the prefix is pent, we know that it has 5 carbon atoms. All right, let's remind ourselves of the general formula, CnH2n. All right, let's work out the molecular, ladies. What would be the molecular formula? So C5H10. Now we need to draw, right? So we need our fully displayed structural formula. So again, remember the advice. Start with your carbon chain or your backbone. 1, 2, 3, 4, 5. All right. Now for now, ladies, because we're just practicing, for now, we can put the double bond anywhere we like. However, come Monday, we're going to get a little more specific with where that double bond lies. So just picking random and I'm putting it there. This is just random, ladies. No special anything about it. So I'm putting it here. All right. Now I need to decide the bonds that will be available for my hydrogens to bond to around my carbon. So all others will have single bonds in between. Now remember that the single bond represents a bond between the 2 carbons there. So how many available bonds will be for carbon number 1? So we're at this carbon. How many bonds will be available around it? 1, 2, 3, or 4? Yeah. So look on it now, ladies. Remember, it must have a total of 4. I have 1, 2, 3, 4. That's my 4 for carbon number 1. What would be for carbon number 2? 2 more. Excellent. Carbon number 3 be 1. All right. So look at it again, ladies. We have 1 in the back here, 1 at the top. That's 2, 3, and 4. So always practice counting off the bonds. All right. Because remember, carbon maximum 4. All right. What about the 4th one?
3.
3.
3.
Excellent. Excellent. So these are my available bonds now to put my hydrogen atoms. Now, oftentimes I get this question, ladies, about these 1-1 bonds like here and here. Miss, do you always have to put it at the top? No, you don't have to. It can be placed at the top or at the bottom, to the side, as long as they're surrounding the carbon atoms. All right, ladies? When it comes down to like 1, I don't always have to put it on the top. Sometimes I put it on top because of space. So if we were at school and I'm on the board, you know, I need the bottom part of the board. So I like to put them on the top. All right? So let's drop in our hydrogens and complete our structure. And that's what it will look like. So this will be the structural, the fully displayed structural formula for pentene. All right, so now we need to write our condensed version. That's what we need to do next. So remember, with our condensed version, we're taking each carbon atom and writing how many hydrogens are attached. So let's go with carbon number 1. How many hydrogens?
3.
2.
2.
Nice. Carbon number 3.
1.
1. All right. Now, this is where the difference comes in now with the alkanes and the alkenes. Because I have a double bond between carbons number 3 and 4, I'm going to show it in my condensed formula. So I put my double bond in, and then I continue writing. Carbon number 4 is 1, and carbon number 5 is 3. So that's what my condensed formula for my alkenes will look like. I move on to alcohols. Ready?
Yes, miss.
All right, beautiful. All right, so let's move on to alcohols. All right, now with alcohols, remember that we have our functional group that we need to consider. All right, our general formula for alcohols, CN H2N plus 1 OH. So that's our general formula that we're working with. CnH2N plus 1 OH. So remember now, wherever we see N, we're going to substitute it for the number of carbon atoms. So at this point, we can choose random. Let's do an alcohol with 3 carbon atoms. All right. What would be the name of this compound? So the prefix for 3 is prop, and the ending for our the alcohols, anol. So propanol is the name. All right. Now we're going to write the formula for propanol. So we have C, and we're going to substitute our N for the number of carbon atoms. H2, substitute N again, plus 1 OH. Now let's tie it in together. C3H, 2 times 3 is 6 plus 1, 7 OH. Awesome. That's our formula for molecular formula for propanol. How would we draw this? All right. So it's the same instructions, ladies. Draw your carbon backbone. So my carbon backbone, 3 carbon atoms. And so I'm going to draw the 3. 1, 2, 3. Nice. Surrounding my carbon atoms, I have hydrogen as well as my functional group. Now, let's see the bonds between. We have single bonds in between the carbon atoms for alcohols, but I must have my functional group, which is the OH. All right. So let's look at the rest of the surrounding. And I put my hydrogens in. And that will be your structure for propanol. So it wants to look like an alkane, but what makes a difference is the presence of this OH group. Once I see that OH attached to a carbon atom, right away I know, oh, this is not an alkane anymore. It's an alcohol. And then lastly, don't worry, you're going to get the chance to record it. Lastly, we need to do our condensed formula. So, same principle, ladies. We are going to write the carbon in order and put the surrounding atoms. So, carbon number 1 has 3 hydrogens. Carbon number 2 has 2. Carbon number 3 has 2, but it also has OH. And that's it. Last example, ladies. Last example. So the last example that we're going to look at are the acids. All right. Now, the general formula for the acid is CnH2n plus 1 COOH. Now, acids are a little tricky. All right. So the functional group for an acid is this here. All right, I'm trying to color it so you see it better. COOH, that's our functional group. Now, the problem with acids is that within their functional group, within the functional group that must be there, comes along with a carbon. So whether or not it was going to have a carbon atom or not, which you know it must, right? Carbon comes along with the functional group. So you know what's going to happen now? This carbon that's going to throw off everything, you know. I am now going to have to consider when I am writing my formula, right? Remember this N here? I am going to have to always consider this carbon that I already have by default. So, to figure this out, this is what we normally do. Whatever number that you get to be N, subtract 1. Because by default, you have this 1 carbon atom already. So for every acid, you have started off with 1 carbon atom by default. And then you need to add the rest in the chain. So let's do an example. Let's do 4 carbon atoms. All right. What's the prefix for 4? Nice, but. And because it's an acid, it's going to end with anoic acid. So the name of this compound would be butanoic acid. Excellent, excellent. All right, butanoic acid. Now, what we're expecting is that I am to have 4 carbon atoms in my chain. Good. That 4 carbon atoms in my chain also, right, the carbon came, one of the carbons came from the functional group. So all I'm going to have to do is subtract 1. So N for butanoic, I'm not going to use 4. I'm going to use 3. So let's go. C, 3, because it is now N minus 1. H, 2, 3, because remember we're still using the same N numbers being 3, plus 1, and then I'm going to have my COOH. So my formula then will be C3H7COOH. If you're all right, and to prove it, don't write anything else. Remember, I'm going to give you the chance to write. To prove it, I'm going to draw it for you. So I'm going to look at my formula and I'm going to draw it based on my formula. So let's go with the structural, all right? Now, just to prove it to you, this is what I'm going to do. I'm going to draw this part first. The C3H7. 1, 2, 3. 1 hydrogen, 2 hydrogens, 3 hydrogens, 4 hydrogens, 5 hydrogens, 6 hydrogens, 7 hydrogens. Now I'm going to draw the functional group part. C O O H. So look in the line now, ladies. Do you see where we have 4 carbons in the line now? 1,
Yes, miss.
2, 3, 4. Yeah. So when you're drawing it, to be honest, students like to draw it first and then write the formula. But either way you take it, you have to understand it because you don't have time to draw all the time, ladies. So if you're drawing it, it becomes a lot clearer to you. But when you're writing the formula for an acid, just remember that your acid, your functional group for your acid brings along with it its own carbon. And so you just need to subtract the 1 and work with 1 less with your N. So that is what butanoic acid would look like for the structure. And then lastly, we can do the condensed part. So the condensed is CH3, CH2, CH2COOH.